Hi, Algo fan. Welcome to the session 2 of our TypeScript Bootcamp. Thanks for joining us and starting this journey. A quick recap of yesterday's session. We improved our smart contract and added boxes. On the chat, you can share your thoughts on yesterday's session and let us know if you were able to recreate the improved contract for the marketplace. And today, as we did on the Beginner Bootcamp, we're going to create the test. To ensure that everything is working as we expect, we are almost ready to start today's session. Who is ready for the content that Giorgio has prepared for us? Hi, my friend. How are you doing today?
Hello. Yeah, I'm ready. Let's do it.
Awesome. And a quick reminder, the sessions are recorded, and once the session is over, you will receive the recording in your email. In session 4, I will share the link so you can claim the certificate of completion, and all the people that had claimed all the certificate will receive a wonderful surprise. So now we are ready for day 2. Giorgio, over to you. We are ready and how we are going to work in today's session. You mentioned that we are going to do some live coding. How is going to be the process today?
Yeah, exactly. So today we're going to, sorry, Camila, I'm going to mute your microphone. So exactly. So today we're going to write the tests for the contract that we wrote yesterday, and it's going to be a live coding session. And yeah, like now, to introduce this work today, we will be writing positive tests. Oh, sorry. Close the notifications on my phone. I apologize about that. And we're going to write positive tests about our contracts, which means that we will verify that the contract works as we expect it to. What we will not be doing, which I encourage you to do as a homework or as an exercise, is to write negative tests. So we also want to feed bad inputs to the contract and see how the contract performs under inputs that it does not expect. So I think we are ready to start coding.
Awesome. So one last reminder, if you have any question, you can use the question tab on Linestorm. In that way, it's easier for me answer the questions. And also, after the session, you will have everything in just one place. So thanks so much, Giorgio, and we are ready.
Perfect. Okay. So let me open the window for my editor. Okay. So, I mean, let's review what we have in the contract very, very briefly. We wrote a box mapping. So for each box, we have a listing, and we have a method to allow assets in the application. This is not by the user. I mean, assets only need to be allowed once, and that scales infinitely with the number of users. Then we have the first deposit, which is different from the deposit because in the first deposit, we have to have a payment transaction, which makes the signature of the method different. And therefore, since there's no like method overloading in general, in TypeScript or in Python, the methods need to be called differently. In this first deposit, we create the box and we save the state. And in the other deposits, the box is already created, so we don't need the pay to the contract. And set price is a method used from the seller to set the price of a listing. Buy, this is used from a third-party account to pay with an attached transaction the owner of the listing. It selects how much of the ASA they want to buy. And you can see that the smart contract verifies that the seller is getting paid and then unlocks the assets. And then we save the new balance for accounting in the box. Withdraw will close a listing, and therefore the algos are already in the user balance, because as we just mentioned, the payment goes from the buyer to the seller directly. So the only thing we have to send back is the MBR for the box that the seller that the seller deposited into the contract, and then we send them any leftover asset, and we delete the box. So this is the summary of what we have. And now we want to take a look at the tests that come with the default template. The default application, if you recall, it's kind of a calculator. So it has a sum and difference method and also a hello world method. They are now highlighted as wrong because, of course, we changed the contract, we changed the client. So these are no longer methods that appear on this digital marketplace client. A couple of disclaimers before we start writing tests. As I mentioned, the tests will be positive tests. And the other thing to mention before we start is that, contrary to the usual way we do unit testing, when we test smart contracts, we want the tests to happen in a sequence because the effects of the tests will build on each other. For example, it wouldn't make sense to test the deposit method if we didn't test the allow asset first, right? Because the first is a prerequisite for the second one. So without going on anymore, let's just start. And we want to delete the tests, two of the three tests, because we will going to be modifying this one in a bit. And we want to notice that we have also an Algorand client, just as we did in the Python bootcamp. This Algorand client is an abstraction over the Algorand SDK, so it will allow us to send transaction more easily, and it will hide and it will solve some details of sending transaction and attaching transactions to method calls. Very well. So we will, first of all, we will create the test setup. We will create some test assets to use in our testing. So the way that we're going to do that is test assets ID. And this will be simply a tuple. And I'm going to have to write it in this way because the way that an asset is created, this is what the asset creation returns. Maybe we'll check it later if we change it, but this is essentially means we are allocating a variable, a tuple for two assets. And now we want to actually, so we notice that we have this test account, and this test account is the default account that is given to us by the AlgoKit utilities. However, we want two other accounts in our testing. We at least want a seller and a buyer that are different than the creator, because if I highlight the test account, you can see that it is highlighted in the digital marketplace client, which means that this client will send method calls from the test account, and we want to actually send method calls from a seller and a buyer. So I'm going to do something that I don't think I did already. I'm going to start Docker on my machine. And in order for us to start with a clean local net, we're going to issue a local AlgoKit local net reset. Okay, perfect. So what we want to do is, as I said, create 2 new accounts that are going to be new each test run, but they are going to be the same for all the tests in a single test run. So we do this by using a function in the ArcoKit framework called get or create, and we want the name to be the stable seller, and we want this account to be funded with algos. We will need to import this, as we can see, and let's fund the account with 100 algos. Okay. I see. We also need to pass an algo D client and a KMD client. I'm sorry for all the pop-ups if you can see them. Okay, let's use our trusted utility. So npm run fix. I'm not in the project folder. I always make this mistake. Contracts, npm run fix. Okay, so this is we created an account called a stable seller, and we actually need to do the same for the buyer. So we will do this the same way, only we will call it a buyer. Let's see. Okay, so now that we created these accounts, let's get them. And we will, because we want to get them from the Algorand client and not from AlgoKit itself. Otherwise, we could also get them with this function directly. But since we want to get them for the sake of the code that we are going to write next, we want to get them from the Algorand client. So this is why we are getting them a second time. It looks like we're getting them a second time. Algorand account from KMD, and now we will find an account that is called stable seller. So this client is fine. We want it to be created by the test account. However, now we want to also create the asset themselves, right? So let's do it here. And we will say that the variable that we allocated is going to be, we're going to assign something to it, and we're going to say that. So I'm going to use this a lot anytime that I'm using like awaits and asyncs. I'm going to use promise all. You will see in a second how. So we want to return actually a tuple. So let's create an asset. Algorand send asset create. And the sender, as we mentioned, is going to be the seller. Oops, stable seller address. And the signer will be, although I don't know if we need the signer actually, let's just try it this way and then we'll see. The total supply of the asset that we're creating is going to be 10 units. I'm saying 10 units because of course we're going to set, based on the yesterday's discussion, we're going to set assets with 3 decimals because it makes the calculation more interesting for us to check with tests. So this is only one. This is only one asset creation, and we actually. So if you can see the error, it's basically saying that this will return a transaction, and we don't want the whole transaction. We only want a field within it. So let's wrap this code within parentheses, and then we extract the field confirmation asset index. This is still going to complain because it doesn't know that this field is necessarily set. However, you can see that it is potentially undefined, but however, we know that this will be set because the type of transaction is an asset create. So we are free to use exclamation symbol to represent the fact that this cannot be undefined. So okay, we only need to do this a second time, and we're done. So in this way, we're creating two test assets. They are the same characteristics. They will have different IDs, obviously, and we assign them to this global variable. What we want to do, actually, after creating the application, is actually funding the application address. With algos 0.1. So we're going to give the application address just enough algos to have a balance. And after this point, any MBR related to asset will have to be provided with the method call. So yeah, I think we're good to write the first test, and we will start to get familiar with how testing in TypeScript works. So this test is called allow asset. And we want to bring in some things that we already saw in the setup, in the test setup. And we want to bring in an Algorand client. So Algorand, this is equal to fixture. And we will use this Algorand client actually to get back the same seller. So this is why I called it a stable seller, which I remind you is also the creator of the assets. So const stable seller, this is equal to count from KMD stable seller. Okay, perfect. And well, actually, let's see if creating the test asset works. And to do that, I want to open the terminal and do advocate project run test. Okay, perfect. It passed. So we can see that the asset creation went fine. So now to test the allow asset method. So what we want to do in general when we test a smart contract is to measure the impact of and these effects of that method. So in this case, we want to verify that this method actually made the address of the application opt in that asset. So we want to measure that at this point the contract is not opted in that asset. We want to call the method, and after that we want to measure that the contract is indeed opted in the asset. So I'll show you how to check for something that's supposed to fail. In general, this will be the pattern that we're going to use. We're going to use promise all and then iterate over the test assets. like this. And so for each asset, we will create an asynchronous function that is going to be awaited by promise all. And this asynchronous function should be that we expect the asset information for the, oh, no, I forgot to get the application address, but I will just write it and we'll see where this method is going. Objects to be defined. Okay, so in essence, we want to call the get asset information on the application and the asset, and we expect it to fail because the contract is not opted in. And this is different from the state after the contract, because even if the balance of an account for an asset is 0, it should still result in a successful query. If the account is not opted in, this query will fail. So we expect this query to reject. And as I mentioned, I forgot to get the application address. And we will do this by app client, and get app reference. And the app address, perfect. So already this should work, right? Because we expect a newly created contract to not be opted into anything. So we want to measure, this will allow us to measure the difference in effects after the method call. I mean, if this takes too much time, I may. Okay, perfect. So we can see that this correctly catches the error. So the way that we want to call the method is, I'm going to show it right now, and it results, because this will be an array of results, because we're going to call the method 2 times, for one time for each asset, and it's an await, promise all, you know the deal by now. This map sync asset, and then we want to call allow asset. So the allow asset wants an MBR pay, and it also wants an asset. And the asset, I mean, we could write this, right? So asset is equal to asset, but since they have the same name, this is simplified in TypeScript. And this MBR pay, again, I mentioned that we are going to use the Algorand client to create transactions, and in this case, this is a payment. Sender is the seller. The receiver is the app address. The amount is Algos 0.1, which we know this is the amount to opt in to an asset. And we're going to also give this an extra fee of micro Algos 1000, the minimum fee, because we know that this method, application method, is going to issue an inner transaction as the asset opt-in. This is not in the correct place. This should be right after. No, it was in the correct place. Let's try and fix the code. Okay. And another thing that we will do a lot of, and that we mentioned already, is that the application client is set to send the transaction with the test account, right? And we don't want that. We want to send method calls from the stable seller. So let's do that. We need to use the other arguments of the client. So if you notice, the first object, like this object here, are the arguments to the application call, and this right here, which we will use, again, these are the arguments for the transaction itself. So the sender, like sort of like metadata about the transaction. Okay, so now we want to measure that that this transaction executed successfully. And we expect each result confirmation to be defined. But now we also want to measure the effects of the application call. And so again, same prelude for each asset to have an async function. And here we want to read, again, we want to read the balance of an application for an asset. But we will do it in a slightly different way, because this time we don't expect it to fail, but we expect it to be successful. And we also will check what the result of that query is. So we expect get asset information for the app address and the asset to resolve, and we expect the answer of this resolve. And we're going to use some kind of strange syntax, but we will let me write it and then we'll talk about it. Okay, so we are just saying that we expect the balance for an asset to be 0 and it not result in a failure. So let's confirm that this code works. Okay. And I want to show you why I'm using like this kind of equality with an unexpected object containing. So let's say that we have another field called foo, which we expect to be bar, right? And let's watch what happens to the tests now that we have this. Oh, I didn't expect this to happen. So maybe let's do this is strange. Let's see if this helps. I'm trying to trick the tests into failing. but I want to have them failing in a kind of particular way that shows us why we are using this code. Huh. This is strange. Okay, let's not worry about it. Maybe we can review this at the end of the session, because I was expecting something else. But anyway, the gist of it is that this function returns a larger object, and we don't want to check against all the fields of that object. We want to check only against a subset of fields of that object. So this is why we only care that it contains at least these two fields, and if it contains anything more, we don't care about it, essentially. So this test confirms us that allow asset works, or I mean that we measure, more precisely, we measure the effects that we expect. Now we're going to test first deposit. We're going to copy this setup from the test, because we need it here too. And we can already call the methods in our contract. So results, this is equal to await promise.all. And the way that we want to, what we want to test is that the balance of the contract changes accordingly, and that what we store in the boxes is coherent with what we deposited. So app client first deposit, and this takes an MBR pay to pay for the box. So we're going to create this transaction with Algorand, with the Algorand client. Sender is going to be the stable seller address. The receiver is going to be the application address. The amount is going to be, well, we should probably take this number from the contract that we computed and probably have it in the tests too. Just because we don't want to have too many things encoded. So this is the for sale MBR, and this is what we want to send to the contract to pay for the box. For sale MBR. Now this method also takes the actual deposit transaction. So an asset transfer, essentially. And the asset ID is going to be the asset, which we are iterating over. Sender is the stable seller. The receiver is still the app address. And the amount is just a constant, let's say 3 units. The first deposit is going to be 3 units. Other arguments are nonce, which we will set to 0 as a constant, and a unitary price, which just for the moment will be 1 algo expressed in micro algos. Let's fix the code. I forgot the point address, and this should be a big integer. Now we need to remember that we want the sender to be the stable seller. The sender of the new method call. And now I want to actually point out a difference, like a characteristic of the Algorand client. You can have Algorand.transactions, and this will return a transaction that you can use to attach it to a method call. However, we have already used it in another way. You can do Algorand.send, and this will not return a transaction because this will create a transaction, but also send it to the network and wait for confirmation. So the result of a send something is the actual value of the transaction, of the confirmed transaction. In this case, we are only attaching it, and they need to be grouped together. So we just need to return the transaction at this moment. Right. We want to verify that all our results, we expect them result confirmation to be defined, so that we know that the calls at least reached the chain and they executed successfully. Now we want to measure the effects of this call. So I mentioned that we want to check the balance and we want to check the box content. Let's start with balances. Test asset ID, this is same every time. We expect Algorand account, we already did this, the asset, the application address for that asset to resolve to an object that is equal or at least contains the asset ID of asset, only wrapped in a big int, and the balance of what we just deposited. And we decided to deposit 3 units. So that's what we're going to check for. Only wrapped in a big int too. Fix the code. And let's see if this runs already. It should. We can at least verify that the balance changes. Okay, so we are passing the first 2 tests already. Let's add a check for the box content. We want to verify that the content is doing the proper accounting. Okay, so we're trying to get the box value, which we call box content, of the listing. So what identifies a listing uniquely is the owner of the listing, the asset, and the nodes. So we need to actually, I think we talked about it. You can see, for example, in the first, well, it's not super, like the underlying mechanism with which a contract in TypeScript takes an object and uses it as the key to a box is that it takes the bytes representation of each field and it concatenates that those bytes. I think we should be able to see this actually in the compiled code. You don't need to do this, but maybe it's a nice detail. So if we want to take a look at deposit. The deposit method. This is first deposit. We'll take a look at just deposit, whole words. There you go. So we are in the deposit method, and we can see that this line, which is this line where we get the box, this takes the sender, the asset for that transaction, and the nonce, and then it concatenates all of them. And this is used with the boxlen opcode to assert that the box exists. Now, these are details that you don't necessarily need to know, but we only need to understand how this object is converted into a key. We take the fields, the bytes representation of the fields, we concatenate it, and we use it to get the box. So we're going to have to do the same in the tests. Just so that you have some context about what we're doing. We want to take the bytes representation of get account address as a byte array, stable seller address, and this will be the first component of the key. And we're also going to concatenate a number, which is the asset ID, and copy this line again to have it 0. So these bytes are the concatenation of the address, the asset, and the nonce equal to 0 for this test. And we use it to find the box and the content. So now that we have the content, we extract the values from the box content with decode a number, box content, slice. And by the way, the opposite is also true. So when we actually write, we assign an object to the value of the box. The fields are converted to the bytes representation, concatenated, and written to the box. And in the testing, so we are going to get, so the box content is, you can notice that it is a byte array. And from this byte array, we need to slice it and reconvert back to a number or to whatever your information, however your information is encoded. Yeah, this needs also save. Then we can have the same, but for unitary price. Only we go from 8 to 16, and we expect the box deposited to equal 3 units. So we expect the accounting to be done correctly, and we also expect unitary price to equal what we selected as the input. Okay, so this should already work. Run, let's fix the code. Run test. Perfect. So the first deposit test is also passing. Now, since we want to kind of do the same thing for the deposit test, I want to just make a copy of this. And we will modify this to be deposit. And we only need to make a couple of adjustments, not too many. This becomes a deposit, which means that we don't need to pay for a box and we don't need to select a price. This stays the same. We actually want to modify the new deposit, which is going to be 1 unit. So we expect the new balance to be 4 units. And also the new accounting should be 4 units. And I believe that this is enough for the test to pass. I can see a couple of comments saying that I should increase. I'm already, I think, I can try it. This is actually the maximum that I can go to. Sorry about that. But if you make your screen if you make your window full screen, it should be better. So let's check the tests. Right, so we passed also the deposit test because it's in the same spirit as the previous one. We only need to check different things. We want to test the set price method. We will need an algorithm client. From BMB stable seller. And okay, we want to iterate over the assets. No, we actually want to do something different. I'm going to construct an array of test cases, should we call them, for the set price. So not only am I going to pass a test asset, I'm going to pass a new price for that asset. So in this case, I'm going to create an array of tuples. And the second is algos, 3.2 algos. And the second test case is the second asset with a different price of 5.7 algos. So we are doing things this way because then we execute the same method, but for different assets, we set different price. You will see that in a second. And then we want to map over this array an async function that takes an asset and a unitary price and returns a client set price. We fix the code for you, just a second. Okay, so the asset is going to be the one that we are iterating over. The nonce is going to be 0 because that's the constant that we're using in the tests. And the unitary price is going to be the unitary price that we specified in the test cases. So is this fine? Okay. And yeah, since we're using a method call with the client, we want to also say that the sender is equal to the stable seller. But that's about it, I think. Okay, again, we want to verify that all the results, all the calls executed successfully, and then we want to actually measure the effects of this method. And we're going to read the content of the box once again, because we expect the box content to have changed. If we see the set price, we are changing the content of the box. So we're going to write some code that's very, very similar to this one. So I think, let me just be just a little bit lazy and do this. Again, we want to read the box content. I mean, this is the same key as before, so let me just be a little bit lazy and copy the content of the box. And we want to only check the unitary price. We could check also the deposit, but again, we're not going to do negative tests. We're going to only to do positive tests. So let's check the unitary. Let's decode from the box content. The price starts at 8. And we expect this box unitary price to equal the unitary price. Okay, I'm thinking this should work. Okay, nice. So up until set price, we are measuring the same things that we expect. Now, we only have 2 tests left, so maybe this will be a good time to answer some questions if we have any. Let me check. Doesn't look like it.
No, so far we don't have any question, George.
Okay.
The people is paying a lot of attention, and maybe once they try to replicate the code, they will have more questions and they can ask us on Discord.
Yes, absolutely. Let me just get the same prelude from here. No, we actually want a different thing this time. So we want a barrier this time. Okay. Since this is a brand new account, each test is going to be new, we want this account to actually opt in the asset that they are buying. So let's try to do that. Sender is going to be the buyer address. Okay. Very nice. So we perform the opt-in from the buyer side to each asset, and now we're free to call the buy method. So the buy method, we first need to send the information to identify a listing. So this is the owner, and this is why we need the stable seller address, the asset. It's going to be the asset, and the nonce is going to be 0. I'm thinking we should probably do the same for this iteration as we did for this case right here. I think we want to have a vector of test cases rather than... Okay, so with the first asset, let's say that we want to buy 2 units, 0.123, just to make the number a little bit strange. And this is now an asset and an amount to pay. We should calculate the price for this quantity, the amount to pay for this quantity and this price. So if I get my calculator, I can see that 2.123 units times 3.2, that's the result. This is the result. The dot. And let's do the same for 2.123 units times 5.7 algos. This is the result. Okay. So now we also want to create the buy. Now that we know how much we need to pay for each order, we want to create an Algorand, transactions, and a payment. From the sender, which is the buyer address, and this time directly to the seller, stable seller. Amount should be in algos, and it should be amount to pay. Okay, and we also want to send an extra fee for the cost of this inner transaction here, this asset transfer. So this should be 1,000, which is the minimum fee. Let's see, and then quantity. And again, this time, the sender of this method call should be the buyer. Let's fix the code. Okay, very nice. So this is kind of repetitive, I know, but nevertheless, we need to do it. Expect the result confirmation to be defined. Try to be as quickly as possible. So now we want to measure the effect of the buy, which means that we want to measure the balance of the buyer and we want to confirm that they have the assets. Now, I will bring your attention to the fact that we didn't check the balance of the buyer prior to calling the method because we just opted in. So we know that if this doesn't fail, the balance is exactly 0. I'm not doing anything new, I'm just checking the asset balance for the buyer. So the balance, we just bought 2.123 units, so that's what we expect to see in the balance. And I'm thinking this should be good. Let's check. Ah, interesting. This doesn't even give us any indication to what test failed, does it? Results is assigned. Hold on. Let's clear the terminal and check if this can give us more information. Doesn't say much at all, actually. Okay, looks like I'm going to do some debugging. This is strange. What if we try to do this? I see. So maybe the issue is, maybe even could it be that this entire test is the one that is making. So this is why it's important to test your progress frequently, because Okay, so we at least know that the error is here, and we know that it is not here because we have commented this, and we know that everything else works. I'm just checking. Oh, I see. Yeah, that will error. Yeah, that will definitely get you into some error. Yeah. Okay, got me worried for a second. Yeah, so the error was that it was a typo in the number, and it was appearing as a triple instead of a pair. Okay, so we measure the same impact, the same effect. We are now missing only the last test for today. We drop. We copy some information. We want the algorithm client and the stable seller. And now, actually, we're not really sure how many algos there are in this account, in this stable seller. So let's measure that before we call the method. Get information about the stable seller, and we want the amount field. Okay, so we know how many algos the seller owns before calling the method. Results. The withdraw wants an asset and a nonce, and that's it. And again, we want to specify that the sender is the stable seller. Fix the code. We want to check that all the results are defined, and then we want to do kind of the same that we did here and call that after call amount. So now we are able to take the difference between the two. So we expect the difference to equal. Well, let's think about it, right? The algos that we get back in the withdraw method are exactly the algos for a box. So since we are doing this twice, because we are doing this for every asset, every test asset, I think that we expect this difference to be double the MBR for the box minus the fees that it costed us to get it, to call the method, right? So this is what I'm expecting to see. We have more to write, but let's first confirm this. This is haunting me. No, we confirmed already that this test works. So, well, just to be sure. I'm sorry, it's just a shame that this test takes so much time to run, because if it ran a little bit quicker, we would debug faster and we would iterate faster. But I can say that we still have some time, so even if we hit a couple of roadblocks, it should be fine. Okay, so it is definitely the latest test that it's getting into some kind of error. And I think I want to check like mistakes or typos. I don't see any. So I'm just, this may be unrelated, but I'm just remembering that withdraw makes two inner transaction. So we need to pass extra fees. Now, what we usually do is we pass extra fees with the Algorand client when we are, passing transaction to the method. But now we only have, native arguments. We don't have transaction arguments. So the way that you can pass extra fees when you are just calling a method is to write send params, and the fee for this method, this is not the extra fee, this is the total fee, because if this were the extra fee, we will write 2000 microalgos. But since this is the total fee, we will write 3000. And since we are paying more fees, we should also update this. Okay. Okay, yeah. So I'm sorry about the unhelpful error message, but this seems to have fixed it because now we have the withdraw test passing. There is one more thing that we need to write for the withdraw method, and that is we want to check the balance of, the balance of the seller, but for the ASAs this time. So maybe we can group these two lines together because they are logically related. And we want to test asset ID, map sync asset. Asset information, this is about a stable seller. Address, and this resolves to be equal to an object containing asset ID, big int asset, and balance we expect it to be, so let's do some, right? We had 10 units, and we sold this number of units. So this is this number here. Why is this getting mad? Ah, yes, because of course we need to also specify an asset for this to give out information about that asset. So, I mean, this is saying that we expect the seller to be refunded of every possible unsold asset. Confirm. Hold on, maybe sometimes it helps to reset the sandbox. Maybe this is why we're not getting such helpful messages, and we're just getting, you know, succinct error messages. I'm just going to run the tests again, just because I'm hoping that I'm going to get some more insightful errors back now that I have reset the local net. But I'm not going to change the test code just now. Okay, yeah, it seems like it was already passing, but you know, when the local net gets really filled with transactions and applications and all of that, because you know we have been running something like 20 runs of tests, it is normal that it needs a reset sometime. Okay. This is all I got. So we have checked the properties of the contract and we have measured the effects, and I'm pretty happy with the result of the testing. So Camillo, if you wanna open it up to
For
questions.
sure. Yeah, my friends. So first of all, thank you for this incredible session. We learn a lot from the errors, and the most important thing is to be able to understand them and try to fix them and don't get mad and frustrated during the process. And as we discussed at the beginning, testing is a very important practice, and today we learn how to start doing that in our contract. And Algodets, how do you find today's session?
So I want to answer Gabor.
Yeah.
Yeah. Camilo,
yeah.
you were going to say
We
something?
have that question about if local net is unreliable.
Yeah. So in some sense, yes, and in some sense, no. What I mean by this is that if you get a confirmation, you are never going to end up with, you know, weird balances. So if I move 10 algos and this transaction succeeds, that is going to be, you know, the correct transfer will happen. If you get errors, yes, in that case, it is possible that you're getting some, not unreliable errors. You will get, it is possible that you start to get different errors because as the size of the ledger increases, the local net is different than the normal network, and it handles the ledger growing differently. I don't know specifically like what is the reason for changing the error message, but I know that it has to do with the size of the ledger. So it's just helpful to reset it if you start to get strange answers. In this
Good
sense,
to know.
so it is, and it is not unreliable in the sense that, I mean, the ledger is a good representation of the network, and you can use it for testing, you can use it for development. However, it does have some flaws.
Awesome. And in some point, it's important to start doing testing on testnet, right? After you do the basic process of testing on localnet, you can move over there to ensure that it's working as we could expect on mainnet. Am I correct?
Yeah, you want to have testing at each level. So I think you want to have like all the testing that you can do on localnet, you should do on localnet because it's for free. But at some point, you correctly say you have to be working with real applications and with real network conditions, because I cannot tell you how many times my tests for my applications on localnet look perfect and they all pass with green marks and all of that. And as soon as I try it on testnet, then testnet is not as immediate as localnet. And there is no substitute for testing on a real network. Some projects go as far as doing a small amount of testing on mainnet. And you may say, well, that is risky. Yes, but you want your application to be working with mainnet apps. If your application, you have to test that at some point. So it is good to do some testing at every level.
The good thing in Algorand is that you don't need to spend a lot of money doing that testing on mainnet. So it's not the best scenario trying everything on mainnet, but you can do it anyway. And I love testing because in that way we understand key features and concepts about Algorand that later we can use in our own project. And Giorgio, what are the recommendations that you can give to us for creating good tests for our contract? What we need to define over there to ensure that everything is working?
Yes. So let me clarify what we said previously. I do not recommend testing everything on testnet and mainnet. You should only test what you cannot test on localnet. But there are some things that you can only test on mainnet, but not you shouldn't run the whole test suite on mainnet. So my recommendation for testing, and we mentioned this at the beginning, it's helpful to write negative tests. And in general, I think for testing, depending on how strict you want to be, you can go as far as tracking the state of all the boxes across all applications. So you need to try and think of the interactions between the elements of the contract. So you need to think in terms of how many elements you have and how they interact with each other. You can see that in this testing, we kind of make everything happen. We kind of make things happen once at a time. And we may want to experiment with it. What happens if I call two methods in a row and I test at the beginning and after the call? So you want to, try and be creative about your tests in some sense.
Awesome. And in these two sessions, we learn how to improve our smart contract and doing the test to ensure that everything is working as we expect. But what we are going to learn in tomorrow's session? What are the things that we still can improve and add to our project?
So tomorrow we will work on the front end for this application. So we will work, thanks to the AlgoKit clients, TypeScript clients, we will work on a React application with which we can execute the methods on the contract. And it will still all be localnet. And depending on how compatible the content is, we may watch the front-end session for the Python bootcamp. but that is completely fine because the front end is still in TypeScript, and it's the only language that we officially, have templates for. So the client abstracts the language, and we said multiple times, AlgoKit is very modular, so this is not a problem because the client will abstract the language of the contract itself. So depending on how compatible the session is, tomorrow we may watch the recording of the Python session. There may be some very, very small difference which we will highlight live. But yeah, we will make a web app for the contract, and we will see how to hook the front end.
We have one question. Is there a listing for the testnet fees? Are those fees the same as on mainnet?
Yeah, so the amount of fees that you are going to pay on localnet, testnet, and mainnet are exactly the same. This is unless we have some congestion on the network, which I don't think has, if the network is congested, so space on a block is precious, then the fee may increase. But I don't think that we've seen like that in normal use very often, if much at all. Maybe just a couple of occasions. So you're not going to get congestion on localnet because that is your private network. So yes, the amount of fees is the same. To acquire fees for testnet, yes, there is a dispenser that you can. Maybe Camilo, can you link the dispenser for testnet?
Yeah, for sure. Hold on a second.
Okay,
we'll take a look.
And that will give you a small amount of algos. And actually, let me show you, because this is a good question. This is a good moment to show you. I'm showing this in my screen sharing. So AlgoKit help. If we take a look at all the possible commands of AlgoKit, not AlgoKit project, AlgoKit, we can see that there is a dispenser integrated with AlgoKit. And this is a different flow from the dispenser that is available through the website, but this will essentially make you log into the dispenser for testnet, and it will programmatically give you algos for your testnet account in such a way that you can also refund the dispenser of the unused algos, and that will allow you to withdraw more and more testnet algos. So as long as you refund the algos that you take out from that dispenser, you're going to be allowed to use a lot of testnet algos, or you can use the just the dispenser that Camilo shared with us.
I already shared the link, so you can try it. And for example, if you are using Pera Wallet to connect to testnet, over there you have the dispenser. So you don't need to go to an external website. Over there you just press the button and they will send you testnet algos. We have another question from Paul. Since storage boxes are on blockchain, can their content be viewed publicly by anyone with the address?
So it's even better than that. In general, you can see you are correct. In general, you can see any information on a blockchain, and so if we pay attention to, if we take our focus to, I'm trying to find the bit where we read the box content. Yes. So in this example here, we are using the client, but in principle we don't have to. We are using the client because the client already knows about the application that we are trying to read from. But in general, box content is readable by anyone, even without an address. You don't have to have an Algorand account, because you don't have to sign anything. It's always free to read from the blockchain. You have to sign transaction and you have to pay the fees to write to the blockchain, but reading is essentially a free operation, free in terms of network fees. You may still have to go through a provider or go through your own node in order to read the blockchain, but blockchain information is absolutely free. And yeah, so you can see that we are just getting the box value, and I'm not signing anything. I'm not. It's free. It's free to read.
Yeah, for that reason, we need to be aware the kind of data that we write on a public blockchain. So how you can send the data, you cannot expose private information over there. So yeah, you can use it, but you need to find a way to send information in a correct way.
Yes, exactly. And we have a question from Douglas. Is there a list of the fees per type of transaction? So every transaction costs the same, and obviously the amount of total fee will depend on the number of transactions that you are executing. They may be group transaction. You can have up to 16 group transaction, and they may be inner transaction, such as in the case of a withdraw or a buy, where we move asset from the contract to a user, but they all cost the same. So it only depends on the number of transactions that you have to perform. Summed, like the sum of group transaction and inner transaction, the total fee provided by the group will have to be at least the total fee used by the group transaction plus the inner transactions. And it's like a faucet to provide fee coverage. So the tools that we showed, like the dispenser, they will give you fee to your account. I'm sorry, they will give you algos to your account. You are free to do whatever you want with those algos. You may choose to use them to make a payment on testnet. You may choose to use them as fees for transactions. You may choose to not refund them to the dispenser. They are just algos that you can use in any way that you want. So in that way, you have a balance that you can use to pay for fees. But in principle, that balance you can use for anything that you want.
Wonderful. I don't think that we have more questions. Hold on a second. I will take a look of the chat. Okay, yeah. Douglas, I was thinking of EVM where there are different fee amounts for different types of transactions. Yeah, so that is the beautiful thing in the AVM. Okay, Giorgio, I don't know if you have any additional comment, any additional thing that you want to share with us.
No, I'm good.
Wonderful. So thanks everyone for joining us in today's session, and looking forward to seeing you in tomorrow's session. You still have time to participate, register for the global hackathon. Maybe in this moment you say, okay, I don't feel that I have the technical knowledge, so you can keep learning, keep participating in these kind of events, and you can participate maybe in the upcoming hackathon also. So thank you so much, and see you tomorrow.